Yes. In the last class we discussed about the velocity of a chemical reaction and velocity constant of a chemical reaction. What is velocity constant of a chemical reaction? That is velocity of a chemical reaction at unit concentration of the reactant. At unit concentration of the reactant. Now, consider so many chemical reactions that we discussed. Actually, consider suppose AA plus BB, that is gives rise to CC plus DD. We are not bothering about this one. If some cases they may give this is considered as a product, this is considered as a product. Then how to predict the velocity of a chemical reaction? The velocity of a chemical reaction, first you have to write the rate law of a chemical reaction, or rate expression of a chemical reaction, or rate expression of a chemical reaction, rate law of a chemical reaction, or rate expression of a chemical reaction is given by rate is equal to, rate is directly proportional to molar concentration of A to the power of A into the molar concentration of B to the power of B in experimentally determined rate equation. In an experimentally determined rate equation. In an experimentally determined rate equation. Experimentally determined rate equation. Experimentally determined rate equation. Therefore, rate is directly proportional to what? Rate is equal to then K into A to the power of A into B to the power of B. If suppose in elementary chemical reactions, if the coefficient, if the reactants they possess the coefficients like that of the A and or B, then a rate equation for the above expression is given by, or above chemical equation is given by, rate is equal to K into molar concentration of A to the power of A into molar concentration of B to the power of B, where this K is equal to rate constant or velocity constant or velocity constant. In some textbook it is rate constant, in some textbook it is a velocity constant of a chemical reaction. Rate of a chemical reaction is more in the beginning because the concentration of the reactant is more. Now the rate constant, this is often called as a rate or a rate constant. Now rate of a chemical reaction, rate of a chemical reaction, rate of a chemical reaction, rate of a chemical reaction depends on, rate of a chemical reaction depends on concentration of the reactant, 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 concentration of the reactant. This is in accordance with the law of mass action, accordance with the law of mass action, accordance with law of mass action, law of mass action, law of mass action. This is true when temperature of the reaction is constant. Temperature of the reaction is constant. Temperature of the reaction is constant. This implies that whenever the temperature is constant, then the velocity or rate of the chemical reaction is directly proportional to the concentration of the reactant. In the beginning, molar concentration of the reactant is more, therefore the velocity will be more. Whereas as the time increases, the molar concentration of the reactant decreases because the reactants are converted into products, therefore the molar concentration of the reactants decreases and hence the velocity of the chemical reaction also decreases. Therefore, velocity of the chemical reaction that decreases from initial concentration to the final concentration of the reactant. very important. But velocity constant of the chemical reaction, it does not changes. At given temperature, the velocity constant value is found to be constant. When the temperature changes, then the velocity constant also changes. At two different temperature ranges, the velocity constant will be different. Velocity constant will be different. Therefore, it does not depend upon the initial concentration of the reactant or final concentration of the reactant. It depends upon the temperature of the chemical reaction. Velocity of the reaction decreases with increase in time, but velocity constant of the chemical reaction always constant. Therefore, velocity constant that depends upon which factors? Velocity constant, it does not depend upon the initial concentration of the reactant. It depends upon temperature of the chemical reaction, and also it depends upon the catalyst, preferably positive catalyst. Therefore, when positive catalyst is used in the chemical reaction, then the velocity constant of the chemical reaction increases. When the temperature of the chemical reaction increases, velocity constant of the chemical reaction increases. When the concentration of the reactant either increases or decreases, velocity constant of the chemical reaction always constant. Very important. In your entrance exam, they will ask the questions, velocity constant of the chemical reaction that depends upon what? Dash. Velocity constant of the chemical reaction. Spell, please read the spell very carefully. Whether it is a rate or rate constant, or whether it is a velocity or velocity constant. Rate of a chemical reaction or rate constant of a chemical reaction. Rate constant of a chemical reaction is independent of the concentration of the reactant. Velocity constant of the chemical reaction depends upon temperature. Velocity constant of the chemical reaction that depends upon the catalyst. Which catalyst? Positive catalyst. Because positive catalyst that always progresses the velocity of the chemical reaction. They always increases the velocity of the chemical reaction, and hence the velocity constant of the chemical reaction also increases. Velocity constant of the chemical reaction also increases. Is it clear? But at two different temperatures, suppose they may give the velocity constant value. At higher temperature, higher the velocity constant. At lower temperature, lower is the velocity constant. And also in some cases, they will, in entrance exam, they will give the various chemical reactions. There is a K1 value and K2 value or K3 value or K4 value provided. The unit of the velocity constant in terms of time is also constant. Then they will ask which one of the following reaction is very fast, which one of the following reaction is very slow. Then velocity constant of the chemical reaction is high, it is a fast reaction. Velocity constant of the chemical reaction is smaller value, it is the slow of the chemical reaction. Fast or slow of the chemical reaction that can be predicted by means of the velocity constant value. For fast reactions, velocity constant value will be higher. For slow reactions, velocity constant will be very slow. That is very smaller value. Therefore, velocity of a chemical reaction, velocity or rate of a chemical reaction, rate of a chemical reaction depends on, what are the various factors that depends on velocity or rate of a chemical reaction that depends upon. These are nothing but the factors affecting the velocity of a chemical reaction. Factors affecting the rate of a chemical reaction. Factors affecting the rate of the chemical reaction. Factors affecting the velocity or rate of the chemical reaction. It depends upon nature of the reactants, whether they are solid or liquid or gaseous one. Solid or liquid or gaseous one. Solid or liquid or gaseous. Nature means that is the physical nature of the chemical reaction. For gaseous reactions, the velocity will be high. Gaseous reactions, gaseous reactions, velocity will be high. Gaseous reactions, velocity will be high. Velocity will be high because the velocity of the gaseous molecules is higher according to the kinematics. For liquid reactions is slow. For liquid reactions slow. Reason, they possess the higher amount of the kinetic energy. Gases reacting molecules, they possess higher amount of the kinetic energy because the velocity will be very high. Because that you know that when the velocity of the molecules will be higher, velocity increases, then momentum increases. When momentum increases, the kinetic energy increases. When kinetic energy increases, then they are gaseous state. Therefore, for gaseous reacting molecules, the velocity will be higher compared to that of the liquid reactions and that of the solid reactions. Second one, temperature of the chemical reaction. Temperature of the reaction. With increase in temperature, the velocity of the chemical reaction increases. With a decrease in temperature, the velocity of the chemical reaction that decreases because they acquire higher kinetic energy with increase in temperature, and hence the collision between the reacting molecules will be higher. When the collision increases, then the number of the effective collisions per second also increases, and hence the more number of the molecules that undergoes collision, therefore it gives rise to the final product. Therefore, increase in temperature increases the velocity of the chemical reaction due to the increase in the quantum of the kinetic energy. Therefore, that also increases the number of the activated molecules. And the number of the collisions and the number of the effective collisions per second also increases, and hence the product also increases because the amount of the product that depends upon not on the amount of the reactive molecules, how many the reactive molecules are effectively participating in the chemical reaction, because some amount of the molecules they are higher energy and some amount of the reactive molecules are lower energy. With increase in temperature, all that does not gains the higher amount of the energy, only some molecules they acquires the higher amount of the energy and they come to the higher energy level and they undergoes collision, and the effective collisions increases, and hence the amount of the product or yield of the product also increases. Therefore, it increases the velocity of the chemical reaction. Usually, for every 10 degrees Celsius rise in temperature, the velocity of the chemical reaction is doubled always. In some cases, it may be tripled. The same phenomena is used in the construction of the pressure cookers, because within the pressure cooker the temperature acquired by the reactive molecules will be high, and hence the time taken by the chemical reaction that is very less. Therefore, when you prepare a food in pressure cookers, it requires lesser time because of the temperature factor. And the designing of the refrigerators and the pressure cookers that based upon the temperature of the chemical reaction. With increase in temperature increases the velocity. In refrigerators, with decrease in temperature, that decreases the velocity of the chemical reaction. Therefore, increase in temperature increases the velocity of the chemical reaction. Increase in temperature increases the velocity of the chemical reaction is increase in temperature increases the velocity. Increase in temperature increases the velocity of the chemical reaction. Increases the velocity of the chemical reaction. Increases the velocity of the chemical reaction. Increases the velocity of the chemical reaction due to increase in number of effective collisions per second. Increase in number of effective collisions per second. Because the velocity of the chemical reaction that depends upon the number of the collisions, simultaneous collisions between the molecules. Therefore, conversely, decrease in temperature decreases the velocity of the chemical reaction. This implies that the in summer season, try to understand, the foodstuffs are easily spoiled compared to that of the winter season. Reason, with increase in temperature, increases the velocity of the chemical reaction. Which chemical reaction occurs here? When foodstuffs are exposed to air, then hydrolysis chemical reaction occurs. Because moisture is present in air, it undergoes hydrolysis reaction in the presence of microorganisms present in air. Therefore, freshly prepared food possesses the pleasant odor. That is because of the ester linkages are there, ester groups are there in freshly prepared, because ester groups always possess a pleasant odor, ester linkages that always possess pleasant odor. Therefore, freshly prepared food molecule contains esters and hence it possesses pleasant odor. But when it is exposed to air, ester linkages undergoes hydrolysis reaction in the presence of microorganisms, then it gives rise to fatty acids and alcohols, low molecular mass fatty acids and alcohols. Low molecular mass fatty acids, they produce a sour taste, that is why sour taste is developed. And unpleasant odor, because low molecular mass alcohols are produced, they produce unpleasant odor. Therefore, unpleasant odor and sour taste has developed when food stuff is exposed to air for a longer period in summer season. That is because of this reason. Because at increase in temperature, the reactivity will be maximum. But when you decrease the temperature, that is why we are keeping the food products in refrigerators, because in order to maintain the low temperature. When you maintain the low temperature, then the microorganisms won't react. Microorganisms won't react because they are deactivated at low temperature. That is why, see, in winter season, when you keep the foodstuff in air, they will not spoil, but in summer season they will spoil. That is because of velocity of the chemical reaction, rate of the chemical reaction that depends upon temperature value. Therefore, higher is the temperature, higher is the velocity, lower is the temperature, lower is the velocity. Velocity is directly proportional to the temperature factor. Is it clear? Okay. Then next one is nature of the reactant and temperature is over, and concentration factor. Concentration factor. Concentration factor. Concentration of the reactant. Concentration of the reactant. Concentration is usually expressed in terms of moles per cubic decimeter or moles per liter. Moles per cubic decimeter or moles per liter. Here the number of moles per unit volume will be increases, means more number of the collisions will be possible. Whenever the number of molecules, suppose this is the number of molecules, this is higher concentration, where is a C1 suppose called. Whenever the number of molecules like this they are arranged, especially in case of the fluid molecules, this is suppose that is equal to C2. If the further the number of the molecules are arranged like this, this is C3. Therefore, C1 greater than C2 greater than C3. C1 greater than C2 greater than C3. Means the number of the molecules which are distributed per unit volume, that is more here. The number of the molecules that distributed per unit area, unit volume will be smaller. The number of the molecules per unit volume will be still lower. And hence here C1 greater than C2 greater than C3 means here the molar concentration will be more. Whenever the number of molecules are more per unit volume, then the number of the collisions they acquired by the reactive molecules will be more. They collide with one another effectively, because here the molecules are far away from each other, the number of the collisions are less, rate of the collision, that is the number of the collisions per unit volume in per second. Number of collisions per unit volume per second will be more here. Number of collisions per unit volume per second will be smaller here. Number of collisions per unit volume per second will be still smaller here, because the amount of the product that depends upon not the amount of the reactive molecules present, the number of the reactive molecules which exerts collisions, because they hit with one another, they acquire higher amount of the kinetic energy. Therefore, when the more number of the collisions are properly oriented collisions, then only they are responsible for the formation of the final product. Therefore, the orientation is also there. Collisions is not the final ultimate. If the number of collisions will be more, therefore proper orientation should be there in order to give the final product. Therefore, whenever the C1 concentration is more, C2 is smaller and C3 is still smaller, therefore the velocity of the chemical reaction is more here. Therefore, with increase in molar concentration, the number of the moles means the number of the molecules. Number of moles corresponds to the number of molecules. Number of molecules per unit volume per second. When it is more, then the number of the collisions acquired by the reacting molecules will be more. And hence, more proper orientation suppose is there, then ready to give the final product. Therefore, with increase in the molar concentration of the reactant, then the velocity of the chemical reaction will be increases due to the increase in number of the collisions. Is it clear? Because they acquire higher kinetic energy. Higher kinetic energy. In case of the gaseous reactants, then partial pressures are used. Because when pressure increases, the partial pressure increases, then the molecules come close together. When molecules come close together, then only they hit with one another, then the collision rate will be more. Therefore, for gaseous reactions, whenever the partial pressures are more, then the velocity of the chemical reaction is more. In case of the liquid reactions, whenever the molar concentration increases, the velocity of the chemical reaction will be more. Is it clear? Then fourth one, that is surface area of the reactant. Surface area of the reactants. Surface area of the reactants. Larger the surface area of the reactants, then the velocity will be more. Smaller the surface area of the reactants, then the velocity will be less. Therefore, what are the various factors that influences the velocity of the chemical reaction? Nature of the reactants, temperature of the reaction, and concentration of the reactants, and surface area of the reactants, and also in some cases catalyst that also. There is a positive catalyst that also influences the velocity of the chemical reaction, because positive catalyst that increases the rate of the chemical reaction. See the velocity constant of the chemical reaction. Significance of K or rate constant. Significance of K or rate constant of a chemical reaction. Rate constant of a chemical reaction. Very important. In competitive exam point of view, they will ask the four options, which one of the following is incorrect or which one of the following is correct. Rate constant, rate of a reaction decreases with the time, decreases with molar concentration. Decreases with molar concentration or concentration of the reactant. Concentration of the reactant. Concentration of the reactant. Concentration of the reactant. Means depends on time. 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 As time increases, the molar concentration of the reactants that decreases. But rate constant is always constant. Is always constant. Is always constant. Rate constant is always constant. Under any instant of the chemical reaction. Under any instant of a chemical reaction. Under any instant of a chemical reaction. Under any instant of a chemical reaction. Means when you found this K value for T is equal to suppose 1 minute and when that is equal to t is equal to 10 minute, or when that is equal to t is equal to 100 minute, then K value is found to be constant. K value is found to be constant. K value is found to be constant. But rate of a chemical reaction changes. Rate is more in the beginning. 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 As time increases, the rate gradually decreases. But rate constant is always constant under any instant of a given chemical reaction. Under any instant of a given chemical reaction. This is very important. Rate of a chemical reaction decreases, but rate constant always constant. That is the significance of the chemical reaction. Is it clear? Now one more is that we can predict the velocity of the chemical reaction. We can predict the velocity of the chemical reaction. We can predict the velocity of the chemical reaction. We can predict the fast or slow reactions. Fast or slow reactions. Fast or slow reactions by knowing the value of K. We can predict the fast or slow reactions by knowing the value of the K. Suppose some chemical reactions, they will give an entrance exam. Suppose 1, 2, 3 and 4. They will give the K value. Suppose K is equal to, suppose in the range of 10 to the power of minus 2, K1, suppose they will give the K2 is equal to 10 to the power of minus 3 and K3 is equal to 10 to the power of minus 4. Suppose this is per second. Very important. Suppose K4 is equal to 10 to the power of minus 5 per second. If the unit is same, if unit of K is same, if not, you have to convert. If not, you have to convert. One is in, suppose in terms of second, another is in terms of minute, suppose another is in terms of the hour. Then you can convert all these into the same unit. Then suppose this is a fast chemical reaction, because the K value is equal to, it is a bigger value. That is the slowest chemical reaction. Therefore, the velocity of the chemical reaction, velocity constant of the chemical reaction is 10 to the power of minus 2. That's the bigger value compared to 10 to the power of minus 3, 10 to the power of minus 4 and 10 to the power of minus 5. Therefore, the bigger value of the K or velocity constant, that indicates the reaction is very fast. If the smaller value of the K, that indicates the reaction is very slow. Therefore, we can predict the fast or slow reactions by knowing the value of the velocity constant. Very important one in entrance exam, they will give the 4 important questions. They will give the first elementary chemical reaction, example K1 value is equal to this one, K2 value is equal to this one, K3 value is equal to this one, K4 value is equal to this one. Very important, if the unit of K is same, fine. If the unit of K is not same, it is your responsibility to convert. The unit of the K is always in terms of either second or in terms of minute or in terms of the hour. In entrance exam, they may give one is in terms of the second, one in terms of the minute, one in terms of the hour. Then you have to convert in terms of the same unit. Afterwards, you think of which is a bigger value, which is a smaller value. In this, suppose I mentioned all in terms per second is the same value, and K1 is 10 to the power of minus 2, K2 is 10 to the power of minus 3, K3 is 10 to the power of minus 4 and K4 is equal to 10 to the power of minus 5. Then they will ask which one of the following reaction is fast reaction in entrance exam. Keep it in mind that higher is the value of the velocity constant, the reaction is very fast. This is your golden point. Higher is the value of the K, the reaction is very fast. smaller the value of the K, reaction is very slow. Among these, we then arrange the ABCD, suppose the 4 reactions of the velocity of the chemical reaction, where the first reaction is fast, last reaction is slowest, middle is the very slow reactions. Is it clear? Therefore, the second important point, we can predict the fast or slow reactions by knowing the value of the K. Then third one. Velocity of a chemical reaction, velocity constant of a chemical reaction, velocity constant of a chemical reaction, velocity constant of a chemical reaction. In sometimes they are using rate constant, both are same, velocity constant or rate constant. Velocity constant or rate constant of a chemical reaction depends on temperature. Depends on temperature. This is very important. That is, velocity constant of a chemical reaction depends upon temperature. Higher the temperature, higher is the velocity constant. Lower the temperature, lower the velocity constant. Suppose T2 is greater than T1, then suppose this is a K1 and it is a K2 value, then it is to be confirmed K2 is greater than K1. If T2 greater than T1, then K2 that should be greater than K1. In an entrance exam, they may ask, they will give the 4 important reactions. One occurs at 25 degrees Celsius, another occurs at 35 degrees Celsius, another at 45, another at 55 degrees Celsius temperature. In which one of the following reactions the velocity constant will be very higher? Keep it in mind. Velocity constant of a chemical reaction that depends upon temperature. Higher the temperature, higher the velocity constant, lower the temperature, lower the velocity constant. Therefore, among the 4 options where the higher temperature is there, that is the higher velocity constant of the chemical reaction. Therefore, very important one. It depends upon the catalyst, the positive catalyst. It depends upon and depends on positive catalyst and depends on positive catalyst. Depends upon catalyst. Usually positive catalyst. Positive catalyst that increases the velocity constant of velocity of a chemical reaction and hence velocity constant of the chemical reaction. Is it clear? So what about the significance? Velocity of a chemical reaction depends upon the initial concentration, but velocity constant of the chemical reaction does not depends upon the concentration of a chemical reaction. At any instant of a time t, the velocity constant is found to be always constant. Therefore, for a given elementary chemical reaction, velocity constant is always fixed value. You can check at any instant of time t. This is first significance. Second significance, that already mentioned, if suppose the number of the chemical reactions are more, suppose more numbers, then in elementary chemical reactions, they will, in complex chemical reactions, they may give, that is a step 1, step 2, step 3, step 4, they may give this is K1, K2, K3, K4. Then among this, which one of the rate determining steps, then a slow step is the rate determining step of the chemical reaction. Okay. Therefore, if suppose the complex chemical reactions are there, or number of 4 reactions are there, then for some chemical reactions, so that I mentioned already, therefore K1, K2, K3, K4, which one of the following, that is the fast chemical reaction, we can predict by knowing the value of the velocity constant. It also depends upon temperature and catalyst, where the higher the temperature, higher the velocity constant of the chemical reaction, lower the temperature, then the lower. Therefore, it depends upon temperature and catalyst. Molecularity of a chemical reaction. Molecularity of a chemical reaction. Consider a chemical reaction. I mentioned few examples. For example, an ammonium nitrite, on heating it decomposes to give off nitrogen and water molecules. Consider a chemical reaction. Consider a chemical reaction 2HI that gives rise to H2 plus I2. Or consider a chemical reaction 2SO2 plus O2 that gives rise to 2SO3. Consider a few chemical reactions. Consider a few chemical reactions. Or 2NO plus O2, oxidation of the nitric oxide. 2NO plus O2 gives rise to 2NO2. 2NO plus O2 gives rise to 2NO2. Consider these reactions. Since it is a balanced chemical equation for a chemical reaction, the reaction is balanced one. If it is not balanced one, you have to balance the chemical equations. Nitrogen 1 time, nitrogen 1 time, nitrogen 2 time, hydrogen 4 times, 2 2s are 4 times, oxygen 2 times, 2 into 1, oxygen 2 times. 2HI, hydrogen 2 times, hydrogen 2 times, iodine 1 time, iodine 1 time. Here 2SO2 plus 4 gives rise to 2SO3, 2S here 2S. 2 2s are 4, 4 plus 2 is equal to 6, 2 into 3 is equal to 6. Whereas a 2N, here this is a 2N, here oxygen 2, here number 2 plus 2 is equal to 4, 2 2s are, that is equal to 4. Now, what do you mean by molecularity of a chemical reaction? Whereas simply speaking, it is nothing but the number of the reacting molecules participating in the chemical reaction in balanced chemical equation for the reaction. This is a crude definition of the what you mean by molecularity of a chemical reaction. When does the products are found? Then the reacting molecules that react in the sense they undergoes collisions. When they undergoes collisions, that is two simultaneous collisions. Then they're ready to give the product. Which type of the species? Reacting species in the chemical reaction. Reacting species in the chemical reaction. What are the reacting species in the chemical reaction? It may be either atoms or ions or molecules. Either it may be atoms or ions or molecules. I will call these are the reacting species. If only one reacting species is involved, means one atom is involved, or one ion is involved, or one molecule is involved. If two reacting species are participating in the chemical reaction, it implies either two atoms are involved, or two ions are involved, or two molecules are involved. Therefore, what do you mean by molecularity of the chemical reaction? The reaction, the number of the reacting species taking part in elementary reaction, the number of reacting species that taking part in elementary reaction, which must be collide simultaneously in order to bring about the chemical reaction. The number of reacting species. The number of reacting species the number of reacting species it may be atoms, or it may be ions, or it may be molecules. It may be ions or atoms or molecules taking part in an elementary reaction. Taking part in an elementary reaction. Taking part in elementary reaction. Taking part in an elementary reaction, which must collide simultaneously, simultaneously in order to bring about the chemical reaction. In order to bring about a chemical reaction. chemical reaction. In order to bring about a chemical reaction, is called molecularity of a chemical reaction. Is called molecularity of a chemical reaction. The number of reacting species may be either it may be atoms or ions or molecules that taking part in an elementary chemical reaction. Elementary chemical reaction is a single step chemical reaction which must collide simultaneously. This is very important. This must collide simultaneously. This is very important. The number of reacting molecules taking part in an elementary chemical reaction in order to bring about a chemical reaction. This is called a molecularity of a chemical reaction. Very important. Definition. You have to write in exam the same definition. You are not supposed to change any word. The number of reacting species. Here species here corresponds to either it atoms or ions or molecules. Those taking part in an elementary chemical reaction or elementary reaction which must collide. This is very important. Which must collide simultaneously in order to bring about a chemical reaction is called molecularity of a chemical reaction. Molecularity of a chemical reaction may be 1, molecularity of a chemical reaction may be 2, molecularity of a chemical reaction may be 3, but molecularity of a chemical reaction is not a 0. This implies that 0 molecule is participating in the chemical reaction. Molecularity of a chemical reaction is not a fraction, means fractional molecular chemical reactions are not possible. That is nothing but a 0.1 molecule or half a molecule or 3/4 of the molecule or quarter molecule. They are not involved in any chemical reactions. This is very important. Molecularity of a chemical reaction is always whole number. Molecularity of a chemical reaction is not a fraction. Molecularity of a chemical reaction is not a 0. These 3 points are very important. Molecularity of a chemical reaction is always whole number. Molecularity of a chemical reaction is always whole number. You have to write. Molecularity of a chemical reaction is always whole number. Molecularity of a chemical reaction. Molecularity of a, this is very important. Molecularity of a chemical reaction is always whole number. Molecularity of a chemical reaction. Molecularity of a chemical reaction. Molecularity of a chemical reaction is always whole number. Molecularity of a chemical reaction is always whole number. Always whole number. This is very important. Always whole number. Molecularity of a chemical reaction is not 0. Molecularity of a chemical reaction. Molecularity of a chemical reaction is not chemical reaction. Molecularity of a chemical reaction is not equal to 0. Is not equal to 0. This is very important. This implies that if suppose that seems to be 0, 0 molecule is participating means no molecule is participating in the chemical reaction. One more is molecularity of a chemical reaction is not a fraction. Molecularity of a chemical reaction. Molecularity of a chemical reaction is not a fraction. Is not a fraction. Molecularity of a chemical reaction is not a fraction. Is not a fraction. These 3 points are very important for your competitive exam point of view. They may ask which one of the following statement is incorrect. which one of the following statement is correct. You have to remember all these points. Therefore, in some cases you may need to prepare your notes. Molecular type of chemical reaction, first you have to write this definition of the molecular type of chemical reaction, then you have to write the important parts. Molecular type of chemical reaction is always whole number. Molecular type of chemical reaction is not equal to 0. Molecular type of chemical reaction is not a fraction, and so on. Because in some cases, one more question is there, differentiate molecularity and order of a chemical reaction next period. Then you have to remember, then you have to write the part A, part B. That is, the first part is molecularity, second part is the order of a chemical reaction. Then you have to write all this. Okay? Then they are further classified into molecularity of a chemical reaction is classified into unimolecular, bimolecular chemical reactions. Molecularity of chemical reactions are classified into unimolecular, bimolecular and trimolecular chemical reactions. Molecularity of a chemical reaction are classified into molecularity of a chemical reaction, molecularity of a chemical reaction, molecularity of a chemical reaction is molecularity of a chemical reaction is classified into unimolecular reactions where one molecule is there, unimolecular, bimolecular and trimolecular reactions and trimolecular reactions and trimolecular reactions. This is molecularity of a chemical reaction is classified into unimolecular reactions, bimolecular reactions and trimolecular reactions. What about unimolecular reactions? In unimolecular reactions, these are the reactions. Only one molecule is participating in the chemical reaction. Unimolecular reaction. Unimolecular reactions. These are the reactions which involve one reacting species. Unimolecular reaction. Unimolecular reaction. What are unimolecular reactions? Give an example. These are the reactions in which one reacting species means either one atom or one ion or one molecule. These are the reactions involving only one reacting species. Only one reacting species. Only one reacting species. These are the reactions involving only one reacting species. Example that I mentioned, decomposition of ammonium nitrite. Decomposition of ammonium nitrite. Decomposition of ammonium nitrite. Decomposition of ammonium nitrite. That is NH4NO2. NH4NO2. This is nitrite. 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 That gives rise to, on heating, it gives rise to N2 plus 2H2O. N2 plus 2H2O. This is ammonium nitrite. These are the reactions involving only one reacting species. The decomposition of ammonium nitrite is an example for unimolecular reactions. Whereas in case of the bimolecular reactions, whereas the simultaneous collisions between the two reacting species. Bimolecular reactions. What we mean by molecular reactions? These are the reactions which involve simultaneous collision between two reacting species. Bimolecular reactions. Bimolecular reactions. That already mentioned bimolecular reactions. These are the reactions occurs by means of simultaneous collisions between the two reacting species. These are the reactions which involve these are the reactions which involve these are the reactions these are the reactions these are the reactions which involve these are reactions which involve simultaneous collision. This is very important. Simultaneous collision. Simultaneous collision. These are the reactions which involve simultaneous collision between two reacting species. Simultaneous collision between two reacting species. Two reacting species. What are reacting species that you know? Either the two atoms may be there, or ions may be there, or molecules may be there. I will segregate as a reacting species. These are the reactions which involve simultaneous collision between two reacting species. That already mentioned good example, that is the dissociation of the hydrogen iodide. Dissociation of the hydrogen iodide is an example for bimolecular chemical reaction. Dissociation of hydrogen iodide is an example for bimolecular chemical reaction. Example: dissociation of hydrogen iodide. Dissociation of hydrogen iodide. That is 2Hi is raised to H2 plus I2. Dissociation of hydrogen iodide is an example for bimolecular chemical reaction. Trimolecular chemical reaction. Very simple. If you know about the bimolecular chemical reaction, then you replace 2 by means of 3. That's all. These are the reactions which involve the simultaneous collision between three reacting species. That's all. Nothing is there. Bimolecular and trimolecular, the difference only between the two reacting species or three reacting species. Trimolecular reactions. These are the reactions which involve simultaneous collision between three reacting species. These are the reactions which involve simultaneous collision between three reacting species. Three reacting species means it may be atoms or ions or molecules. That I mentioned, that is a 2SO2 plus O2, that gives rise to 2SO3. It is a trimolecular reaction. Or 2NO plus O2, that gives rise to 2NO2. This is an example for trimolecular chemical reactions. Is it possible for tetramolecular and pentamolecular chemical reactions? No. Reactions with molecularity 3 are very rare and slow to proceed. But very important note. Very important note. Reactions with molecularity 3 are very rare and slow to proceed. Very important. Reactions with molecularity 3. Reactions with molecularity 3. Molecularity 3 are rare to proceed. They are very rare to proceed. Reason, the number of the collision rare to proceed. This is because probability of the simultaneous collision between, this is because probability of this is because the probability of simultaneous collision, probability of simultaneous collision. This is because probability of the simultaneous collision between the molecules, between the molecules are very rare to occur. This is simultaneous collision between the molecules, simultaneous collision between the molecules. Between the molecules means 3 molecules. Between 3 molecules. Between 3 molecules. 3 molecules are very rare to occur. Very rare to occur. More than 3 are very slow. More than 3. More than between more than 3 molecules is very slow. More than 3 molecules is very slow. Or more than 3 molecules is very slow. More than 3 molecules is very slow. Reactions with molecularity 3 are rare to proceed or rare to occur. This is because probability of the simultaneous collision between more than 3 molecules is very slow. More than 3 molecules is very slow. This is clear? This is about the molecularity of the chemical reaction. Very important definition of the molecularity of the chemical reaction. And unimolecular reactions, bimolecular reactions, trimolecular reactions along with the examples. And the important points, molecularity of a chemical reaction is always whole number, molecularity of a chemical reaction is not a fraction, and molecularity of a chemical reaction is not equal to 0. How to identify? Just identify the coefficient. If it is 2, it is the bimolecular. If we add, that is becomes 2 plus 1 3, 2 plus 1 is 3, that is a trimolecular reactions. Thank you.